Good day everyone, I am Hazel of Dipungasi and welcome to my vlog. The content of this vlog is related to geology. It is all about the importance of faults in engineering construction. But first, let me give you a brief discussion about faults.
So what is fault and where do they come from? The surface of Earth is like a giant puzzle, and all the pieces that make up this puzzle are called tectonic plates. Although these giant rock puzzle pieces fit together very nicely, they don't stay in place because they are floating on the layer below us, called the mantle. This layer is like the consistency of the silly putty, sort of like a liquid and yet sort of a solid too. The movement of the plates is incredibly slow, but since the plates are so big, when they bump and rub against each other, we get massive events like volcanoes and earthquakes. The movement of the tectonic plates provides stress. In response to this, a fault is formed along the plate boundaries. In geology, a fault is a discontinuity that is formed by fracture in the surface rocks of the Earth when tectonic forces exceed the resistance of the rocks. In other words, a fault is a crack in the Earth's crust. The rupture zone has a generally well-defined surface called the fault plane, and its formation is accompanied by a slide of rocks tangential to this plane.
There are three different types of stress that determines the type of faults that forms: the tensional stress, the compressional stress, and the shear stress.
Tensional stress happens at divergent plate boundaries where two plates are moving away from each other. It is like stretching a rope out all the way and then continuing to pull on it from both ends, putting tension on the rope because it is being pulled in opposite directions. Compressional stress. It happens at convergent plate boundaries where two plates move toward each other. They are literally being compressed into one another. Lastly, the shear stress. Shear stress is experienced at transform boundaries where two plates are sliding past each other horizontally in opposite directions.
Now, let's move forward to the types of fault. There are three main types of fault, and like what I've mentioned, the type of faults depends on the type of stress that caused it. They are the normal fault, reverse fault, and the strike-slip fault.
Due to the tensional stress, it creates a normal fault. So faults have two sides, the hanging wall and the foot wall. In a normal fault, the hanging wall and foot wall are pulled apart from each other, and the hanging wall drops down relative to the foot wall. On the other hand, compressional stress produces reverse faults. In this type of fault, the hanging wall and foot wall are pushed together, and the hanging wall moves upward along the fault relative to the foot wall. This is literally the reverse of a normal fault. Lastly, strike-slip fault is formed due to shear stress. The plates slide past one another without the production or destruction of crust. Because rocks are cut and displaced by movement in opposite direction, rocks facing each other on two sides of the fault are typically of different type of age. This type of fault is also one that causes earthquake.
So now, let us proceed to the main point of the vlog. What is the importance of faults in engineering construction? Faults are important for a civil engineer because these mark the sites where dislocation of the ground has occurred in the past and where such dislocations cannot be entirely ruled out in the future. It is the dislocation aspect which may introduce considerable complications in the site for a proposed engineering project. This may necessitate thorough investigations for the stability of the intended project. Moreover, faults greatly influence rocks, as it has already been made that faults cause very much shearing and crushing of the rocks located along or near the zones. These rocks become weak and unstable on one hand and porous and permeable on the other hand. Engineers has to consider faults from three angles. Firstly, what have been the effects of faulting on the rocks of the region in general and that on the proposed site in particular, especially how far the rocks of the site would be suitable from the strength point of view as foundations or abutments or roof as the case may be. Secondly, if the effect of the past faulting is such that the rocks have not been rendered particularly useless, or in the other words, structures can still be designed and built on them with or without some treatment, then will these proposed structures be safe in the future? Is there no probability of faulting again at the same site during the expected lifespan of the proposed civil engineering project? Thirdly, and lastly, what factor of safety is essential to be adopted in the design and construction of the proposed structure if the site is faulted and there is no alternative available to it? Ideally, the proposed site for any major civil engineering project should be located as far as possible from an active fault and never on active faults, though there are instances that the proposed site is faulted and there is no alternative available to it. That is why engineers must obtain a thorough investigation report about the faults on the project area, so that some factor of safety must be introduced into the design of the structure, especially in the big projects in faulted areas, so that if the unexpected happens, there is minimum loss to the project. So that's the end of my vlog. Thank you for listening.